Hello everyone. In this video we will discuss about generics at very basic level. So I'm thinking of doing two sessions for generics for basics and advanced. So in this video let's discuss only generics at a basic level. So why these are introduced, what is the use case for this in Swift programming language. So let's quickly get into an example where, for example, you have couple of methods. For example, you have a swap method. Method usually swaps two things. They could be of any data type. For example, so if you are writing normally, then what we need to do, we need to write for each and every data type we need to go ahead with the method, correct? If it is a string, if it is a double. But whereas if you look at the logic inside a method, it's same, correct? We take a first value into a temporary constant, and after that we assign it to a, and the temporary will be assigned to b. So that's the logic. So in these cases, instead of having duplicated code, it's better to use the generics. So generic code usually enables us to write flexible, reusable functions and types also that can work with any type, subject to requirements that you define. So we can write code that avoids duplication and express its intent in a clear and abstract manner. So these are one of the most popular features of Swift programming language, where instead of doing all this, how I can write is, so this is the type parameter, which I'm going to explain it in a while, where I'm going to take the same parameters, but I'm not going to mention whether it is integer or string or double, but I'm going to give it like if you're passing something, it is of same data type. Okay, a and b should be of same data type. Okay, now the logic is same, and thus it replaces everything. For example, let me name it as generic swap. So for example, this is view model structure, right? So okay, so if I need to initialize view model dot swap, it can be of integers, for example 10 or 20, let's say, or let's say where a is equal to 20, where b is equal to 50. Now if I do swapping a and b, sorry, now actually I need to pass the addresses. Why? Because inside the function the values are getting interchanged. That is the reason these are inode parameters, correct? So we pass the addresses. So what happens, for example, let's say my view model is equal to view model. Okay, so and I do vm dot swap. Now after doing swap, if I just print my a and my b, I'm sorry, like this, so this is a value and this is b value. Okay, by using the normal functions. For example, just a second, let me understand why it is. Okay, that's fine. Instead of this, let me put it in a view controller. For example, I think I already used it. So for example, view model I'm already having. I just want to swap it, and let me quickly run it. So in the log, if you can see, this is a is 50 and b is 20. These got interchanged. For example, let these be, for example, a is high and b is iOS. So if I run it again, now we should be seeing a as iOS and b as high. So this is working, but the problem here is I need to write so many methods, instead of which I don't want to go with this. Let me comment these, and then let me use only the generic swap functions. Now let me see whether so vm dot generic swap, it could be of any type. So now it actually takes care of the type. That means whatever I pass, and a, and here, and b. Nothing changes actually, but only the function name generic swap I have written. So let's see whether it is swapping or not. Yes, it is swapping. For example, instead of this I want to give double, I want to go with the double, 3.25. so double values I want to see. Now you got 3.25, which is fine, it's happening. So like that I want to go with integers also. One is 5, one is 3. Everything is working only with the power of a single method, correct? So here if we actually look at it, so what is happening is this t something. So these generics are one of the most powerful features of Swift, and much of the Swift standard library is built with the generic code. In fact, so we see generally like, for example, let's say let me take a dictionary. For example, if you can look at dictionary is a key value pale. If you go inside and see this particular structure, let d is equal to dictionary, let's say. So see, it is having two generic types, and array is having something called element. So most of the that we will discuss in a while. So and much of the Swift standard library is built with generic code. In fact, we have been using generics throughout the language, but we don't know that, even if you don't realize it. For example, Swift's array and dictionary types both are generic collection. Dictionary uses key and value as generic types, and Swift uses element. That is the reason if you create an NS array, you can pass any type, correct? You can have a array list of integers, list of strings, and list of doubles. So we can create an array that holds int value, or an array that holds string value, or indeed an array for any other type. Actually, similarly, you can create a dictionary to store values of any specified type, and there are no limitations on what the type can be, correct? So the generic version of the function uses a placeholder type name. So this t, we call it as, it is having a name, placeholder, just the placeholder. It's not the type, it is placeholder type name, it is just the placeholder. Okay, so that based on how you are calling, as you are passing two integers, so it takes then t becomes int. If you are passing two strings, t becomes string. If you are passing two your custom types, t becomes your custom type. Custom type in the sense you can pass your own structures and classes, something like that. So it's not an actual type name, it's just the placeholder type name. The placeholder type name doesn't say anything about what the t must be, but it does say that both a and b must be of the same type. For example, you can't pass a and b of different type, you will get a build error. It must be of the same type, whatever t represents. So the actual type to use in place of t is determined each time when we call generic swap function. So t will be determined at the time of your calling the generic swap method, and what you are passing into this particular function. So actually we can provide more than one type parameter by writing multiple type parameters names within the angle brackets separated by commas. For example, let's say you are having another generic function. Let's say, for example, you are having func for example test. For example, here you can have two parameters, one is t, one is tuv is the standard where we started with, but it doesn't mean it has to be this. You can give any name actually. So here val1, for example, it should be of, first parameter should be of t type, second parameter should be of u type, and it may return something v type. Okay, so something like this. But if you are using v, it should be of this, it should be here, then only. Okay, more than one also we can pass it. I'm just giving here an example. So when it is coming to naming the type, parameters they should have descriptive names. For example, if you can see, for example, if it is dictionary, it is key value. These are not camel case, these start with the uppercase. It is the tradition. Why? Because upper camel case we use, normal camel case we don't use. Why? Because to indicate that they are a placeholder of a type, not a value. To indicate their placeholder, we use upper camel case, where it starts with the capital letter and all, and if you can see, array uses element, so that it makes sense to the placeholder type name. Okay, the placeholder type name what we are keeping should be in sync with the purpose. So in most cases, that type parameters have descriptive names such as key and value for dictionary, and key value array is having element which tells the reader about the relationship between the type parameter and the generic type or function it's used in. However, when there isn't a meaningful relationship between them, then we can go for TUVY, because that's a tradition to use, such as T which we used in the swap. So always we need to give the upper camel case to indicate that they're a placeholder for a type and not a value. Okay, so basically that's what are generics. So instead of anywhere, if you're having if you feel like there is a duplicate of code that's being used, and that can be if only data type is changing inside logic is same, then it is the chance that we go for the generic functions. Okay, these are the generic functions and generic methods. Of course, we can have generic types also. Now let's go to generic types. So generic types means our structures and classes. These are all data types. In addition to generic functions, Swift enables you to define your own generic types as well. These are custom classes, structures and enumerations that can work with any type in a similar way to array and dictionary. Okay, so far you are having multiple functions with the same piece of code. So you have written a generic function. So this we call it as a generic function. Now let's see what is a generic type. Okay, now just coming here, just like what we have seen, for example, you are having a list. It is a structure, and inside a list what we usually have the number of items and push pop. If it is a structure, for example, you don't know what data type it is, and you have multiple data types. For example, it could be int, string, double, like earlier. So instead of having these three structures where only the change is the data type, when you're popping you get the string, when you're pushing you have the string, when there are items you get the list of strings. So in the same way, why don't I comment this piece of code, and why don't I go with my generic type? So in this case, what can I write is, I would just simply take one and paste it here, and instead of this I would say list. Correct? I would say list, and instead of data type I would say T. So here I would say T, here I would say T, here I would say T. Okay, now this has become, this is a, so if I have to say, this is a generic type. I have made some boilerplate code ready so that we won't be wasting any time in this video. So generic, not only generic functions, generic types also we can create if we have same piece of code. For example, list usually have these things. Correct? So for example, it depends on, for example, let list is equal to list list of items. Now here you can pass string. Okay, so that's how you can add list dot items dot append. That's how you can add for example, let's say iOS. Okay, and cannot use, okay, it should be mutating. As it is a structure, it should be having a mutating, so that's the reason it is complaining. And let me add something like solves, like this. I can go for the strings list, and let me quickly see what if it will do if I pass something like integer or a number. I just want to see whether it will give. See, it cannot, you cannot. Okay, so you cannot give an expressions are not allowed at the top level. I don't know what this is, just a second. Anywhere else we have used, Okay, that's fine. Maybe some instead of list, let's say this as a collection. Let's say this as my list or something like this. So let me say it's m list. So that just to get rid of the warnings, maybe the bottom code is having something like this. So pretty much, just a second, why it is complaining, expressions are not allowed at the top level. Sorry, now I understand why, because I'm not in a playground, I am in a Xcode project, so that is the reason it is complaining like I'm writing it the code globally. So just for your reference, so for example, I have taken a list of strings, I have added. If I am giving the integer, see it is complaining. For example, if I say it as an integer collection or stack, then it will complain for the strings. So that's how I can make my type if I am writing something. For example, if I need to create multiple multiple structures for just only because of there is a change in the data type, I think this is the same case where we can go ahead and use the generic type, like which we have used in the functions. We can go with the t or whatever makes sense. For example, here if you feel like okay, element makes sense, so go ahead and use the element. So these are generic types. So now we discussed functions. For example, we discussed functions and we discussed generic types, and what else we usually get into place. For example, let's say I have a protocol, so I just added the boilerplate code ready. For example, there is a user name, phone number we are having. For example, let's say it's a WhatsApp chat where phone number is important. For example, I need to create a protocol, for example a text chat, audio chat and video chat. If you can look at it, every chat will be having something called receiver and sender, which is of user. So every chat needs to be encrypted and needs to be sent. So if you can look at it, text chat will have a string, of course. Audio chat can have a data. Why? Because it's a string, it's a byte data, and video also will have a byte data, correct? If it is a video file that you are sending, if it is an audio file you are sending, it will be having a byte data, which is binary data, which is there in the data format in Swift programming language. So instead of taking these protocols, we can have one generic protocol, I would say, which we call it as something like, for example, let me comment all this so that you will not get confused. Instead of this, I will go with one generic. This is kind of like a generic chat, where in case of protocols, these are associated types. So I think we can have another discussion on the associated types. These are just like I'm making the protocol generic. So a generic protocol, this is a generic protocol. A generic protocol will have a associated type. Okay. So what does that mean by this associated type? That means this also can be of t or any type that you want to play with. That means all the, if you can look at it, here it is having data, or here it is having string. Everything I removed it with, I have replaced that with the chart type. So here there is no change. So every generic protocol will have an associated type, saying that it is a generic protocol. So if you see that a protocol is having a associated type in your code base, that means this is a generic protocol written to remove the duplicated code. Why? Because every protocol is having same piece of code except the data type change. So this is the generic protocol, and how we can use it. See, for example, I have a text chat type alias. I tell my protocol, for example, I am conforming to this protocol. I tell my protocol that this type alias for this chart type is string. That means I am conforming to this chart protocol, whereas my data type is going to be string. So receiver same, sender same, but encrypt and send, if you can see this will be like this. Why? Because instead of this approach, having multiple protocols, instead of a text chat conforming to text chat, now I have a generic protocol where my text chat model conforms to chart and the type alias becomes string. Audio chat conforms to chart and the type alias becomes string. Same applies for the video chat as well. Okay, so to be frank, at very high level, if you see a duplicate piece of code, that means redundant code, only the data type is changed in a function, you can write generic function or a generic method. Or if you see like only data type is different in model, a data type is to be structure, class or enum, you can write the generic types. This is my generic type. That means I have created my type a model, but it can accept any data type. So that's how I can consume it. And if I see a redundant code in the protocols for only the data type is changing in a protocol declaration, then I can go for generic protocols, and generic protocols will be always having associated type, and associated types will be given in the models as type alias. Here it is telling that I am confining to this protocol. To this protocol, it is saying that the type alias for chart type which you are having is a string. So this is how I can use it. And not only that, for these are some examples of generic protocols, like for example processor. A processor used to process input to output, correct? So as I said, type can be input, associated type can be output. It's a generic protocol having two separate data types like t and u, t comma uv, something like that. And when a multiplier class is inheriting is confirming to the processor, it has to say the type alias for input is integer, type alias for output is also integer, and it processes integer, whereas the multiplication, this is the process it is doing, it is multiplying it by 2. But as you can see it, we can have any number of processes like this. I can have additions, I can have strings, concatenation, anything. See, this is the power of generics. Okay, like the transformer, if you are transforming something, for example string to int, into string, into double, double to int, anything, associate type is input and output. So like this we can have generic protocols, a collection, associate type is item, if it is a queue, associate type is element. So basically that's the power of generics, where it can remove the redundancy and make the code very look neat and simple. So when defining a protocol, it's sometimes used to declare one or more associated types as part of the protocol's definition, and associated types gives a placeholder. An associated type is like a placeholder in the protocol, placeholder name to a type that's used as part of the protocol. The actual type to use for that associated type isn't mentioned until the protocol is adopted. Until the protocol is adopted, the actual type that is associated type with is not known. Associated types are specific with the types are specified with the associated types are specified with the associated type keyword. Okay, so basically that's all about the generics. Looks simple but confusing, but at the end it's very helpful and needful. So this is a must known concept, and interview point of view also, where will be asked to, can you write a simple generic function for me, or can you write a simple generic type for me, can you write a generic protocol for me, what does it mean by an associated type, what does it mean by type alias in this, if there is a generic protocol, how can you adopt to it, how you pass the data type to it. So these are very important questions and very important topic as well. So as you can see, instead of going with each and every data type, so generics gives me a feasibility, like I can put a placeholder and I can write my logic here, correct? Okay, so these are just the basics, and we're having some type conformances, where even your generic if you are passing a generic type, if you feel like okay, this should be some it should conform to, for example, so on, so my protocol, that also, so that it will take only the data type which is conforming to the equatable protocol, something like that. So these conformances also we will discuss, for example with respect to associated types. Even associated types, not only the simple associated types, if you feel like this chart type should be conforming to some particular protocol or something like that. So these and all we'll discuss in our advanced generics video, which I am going to make next. I hope this post is useful for you. Thank you.